Today we're going to start to explore a new kind of function which is called a logarithm, or they're logarithmic functions. It's kind of a weird word. But for everything we do to a number, we have to have a way to undo it. So if I add something, I can undo that by subtracting. If I multiply, I can undo that by dividing. If I square, I can take a square root. We always have to have a way to undo whatever we've done. So if we do an exponential, put something to the power of x, we need a way to undo that. And the way we're going to undo that is with a logarithm. So back when we had something like x squared, we could undo that with a square root, right? But now with exponentials, we're thinking about something like 2 to the x, but we can't undo that with an x root, because a root asks us, whatever type of root it is, how many times do we need to multiply? So a square root, we're looking for something to multiply twice. But here we're looking for something, an unknown, to multiply x times, another unknown. We can't do that. So taking a root will not fix an exponential. It'll fix a power, but it can't fix it if that x is up in the exponent. So that's what a logarithm is. A logarithm is a way to undo the exponentials. This is the format of a logarithm. I want us to work on reading it correctly, so we use proper words here and also proper notation. One thing that happens to a lot of students in writing these is you write it a little bit sloppy, and it actually makes it more difficult for you because you can't tell what's what. So we write just log because logarithm's a long word. So we abbreviate it down and just call it the log. Then this little number at the bottom is the base, okay? And it needs to be a subscript, okay? It should be smaller, and it should be set a little bit below it, not on the same level, not the same size. It will be easier for you to tell what's going on if you write it appropriately. Otherwise, everything just kind of gets mashed together. So we've got a log with a base of b. Y here equals x. Okay, so we read that. The log base b of y equals x. This is the same thing as the exponential b to the x equals y. The base is the same. So either the base of the exponent or the base of the log is the same. But in the log, the base is with the y, and in the exponential, the base is with the x. The reason why they switch locations goes back to when we learned about inverse functions. So quite a while ago, back in chapter 7, we learned about inverse functions, and we were just talking about linears then. So we had something like y is equal to 2x plus 3. And we wanted to find the inverse. Does anybody remember what was the first thing we did when we wanted to find an inverse?
What?
What was the first step in finding an inverse to an equation? We studied back in chapter 7. Change x and y. First thing we did was swap out the x and the y. And that's how we create an inverse. So since logs and exponentials are inverses of each other, we see that the base remains the same thing, but the x and the y are flip-flopping who they're with. So before, the y was with the base, and when we do the inverse of it, the x becomes with the base. Okay? So with a log and an exponential, the base stays the same, the other stuff flip-flops its sides. So our first kind of problem today is just going to be working with these logs and exponentials and being able to switch them out for each other, rewrite them for each other. So to rewrite this log as an exponential, the base stays the same, so 2, and the other stuff switches who it's with. 2 to the 5th equals 32. And that's true. 2 to the 5th does equal 32. So the base stays the same. The base is still 2 in both of them, and the other stuff flip-flops who it's with. So the 5 goes over to the left, and the 32 goes over to the right. So our base stays the same, 5, and the other stuff switches sides. So 5 to the 0 is 1, and that's true because anything to the 0 power is 1. Our base stays the same, 10, and the other stuff switches sides. 10 to the first is 10, so that's true. So it's kind of nice when we're doing these first ones that just have numbers in them and we're turning them into exponentials because we can verify that we did it right because you should get something that's true. Now to do this backwards and go into log form, we're going to say log, the base stays the same. So log base 10, and the other stuff switches sides. So of 0.1 equals -1. The base is still 10, but the other stuff switches to its width. So the -1 and the 0.1 flip-flop left and right. Okay, and that 10 as a base, we write as a subscript. So it's a smaller font size in your writing, and it's kind of down half a step there. Okay, just kind of the same idea as how we write exponents. We write those as what's called a superscript. We write them up high and as a smaller number. So to rewrite, we're going to write log. The base stays the same, so our base is 1/2, and the other stuff switches sides. 2 equals -1. There's a couple of special log values that if you can learn to recognize are a little bit easier to simplify problems or to evaluate problems. No matter what our base is, if we take the log of 1, we're going to get 0. Because anything to the 0 power equals 1. Okay, so if you learn to recognize that whenever you see a 1 inside of a log, it doesn't matter what the base is, you're going to end up getting 0. And then if you learn to recognize that if the base and what's inside of the log are exactly the same, it will always equal 1. Because something to the first is always equal to itself. Okay, so those are just a couple of special logs that can come up. Anytime we take the log of 1, we'll get 0. And anytime we take the log of our base, the base and the of are the same thing, you're just going to get 1. Our next problem wants us to evaluate a log expression. Logs become very mysterious things to students, and they're not really sure what's going on here. And I can say even for myself, like I think as a student, I was good at math as a student, and I could do logs, and I don't think I really had any clue what I was doing until I had to start teaching them. And the students are asking me like, but what are we doing? And I'm like, I don't know. Getting the answer. And so that kind of forced me into thinking, like, what's really going on here behind a log? What is a log doing? A log is answering the question of whatever the base is. It's saying 3 in this case. Whatever the base is, 3 to what power would give me 81? Okay, so it's trying to find an exponent. That's what a log is doing, is it's trying to find an exponent. So in this problem, it's saying 3 to what power would be 81. And we can get that from the way that we were rewriting our logs. If we set this guy equal to x to turn it into an equation, then we could rewrite this like we were in that first group of problems and say 3 is our base and the other stuff switches sides. So this is asking 3 to what power is equal to 81. The answer to a log question is a power. Okay, that's what a log is really doing, is trying to find an exponent for us. So as far as solving these, at this point you're going to need to do some guess and check to solve these out. We haven't learned yet how to solve log equations, so these are going to turn into nice values for you. So you're going to want to kind of guess and check it. So 3 to what equals 81? 4. 3 to the 4th is 81. Okay, and you can kind of guess and check those into your calculator. So again, a log is asking the question of what is the power. So this is asking the question of 5 to what power is 0.4. Now we can't do this on your calculator, so we're going to have to find some methods to work this by hand. So again, what I'm going to do is I'm going to set this equal to x, so I can rewrite it as my exponential and say 5 to what power is 0.04. I have no clue, right? So I can do a whole lot of guess and checking to try to find the right answer here. Or we could try to simplify this problem. Okay, so I have no clue what this is. It'd take a whole lot of guess and check to try to get this to the right answer. So what we're going to do is try to simplify this problem the way that it's written to make it maybe a little bit more obvious. And one thing that will be helpful is students don't usually like them, but fractions are easier to see than decimals. So we're going to want to turn this into a fraction. Back in elementary school, you learned like what decimal places are. So that 4 is in what decimal place? The hundredths. So this is the same thing as 4 hundredths. Okay, and that reduces to 1/25th. And now I'm starting to see a connection with some powers. There is a power that 5 to something equals 25, right? 5 squared would be 25, but this is on the bottom of a fraction. What kind of powers move stuff to the bottom of a fraction? Negative powers. So this must be a -2. And you can check that on the calculator and try, is 5 to the -2 0.04? And it is. Okay? So when you're working with a decimal value, it will be helpful to you to turn it into a fraction, because then you're going to be able to see what power should exist there. Once we turn it into a fraction, we could see the relationship between 5 and 25. Okay? So again, a log is asking the question of what is the power. So 1/2 to what power is 8? Or if we set this equal to x, we can rewrite it as 1/2 to the power of x equals 8. Again, we can do some guess and check on this thing to try to figure it out, but there is a relationship between 2 and 8. So 2 to what power would be 8? 2 to the third is 8, but this is upside down again because it's not 2, it's a half. So what turns powers upside down? Negatives. So 1/2 to the -3 is 8. If one of them is a fraction and one of them is not, that power must be a negative, because that negative power is what creates the fraction. So 2 to the third is 8, but since it's upside down, it must be a negative power. So 2 to the -3, or rather a half to the -3 is 8. And you can check that on your calculator to make sure you're getting the right answer. This one is asking the question, 9 to what power equals 3? That's what a log is doing, is trying to find a power. So 9 to the x is equal to 3. Well, they're not fractions, so we're not going to be dealing with a negative answer. But it seems like anything I put 9 to should only make it bigger, right? What kind of a power is going to make 9 a smaller number? A fraction power. We learned a while back that fraction powers have another way to be rewritten. What is a fraction power, really? A root. It's some kind of a root. And whatever the base is tells us what kind of root it is. So what kind of a root do I have to take of 9 to get 3? A square root, right? So a square root is going to be a 1/2 power. Okay, so we learned a while back that fraction exponents can be written as roots. So 9 to the 1/2 is the same thing as the square root of 9. And the square root of 9 is equal to 3. Okay? So if one of them is a fraction and one of them is not, then that power must have been a negative. If the number is becoming smaller by taking a power, we must really be doing a root, which is a fraction power then. Okay? There are two special types of logs that your calculator can do. It can only do these two, okay, and not logs in general. So the last type of questions that we were looking at, you can't just type those into your calculator and have it give you an answer. Right? The calculator cannot do logs in general. It can only do two special logs. It can do a log with a base of 10, which is called the common log. The reason why this is called the common log is our number system is set up in powers of 10. That's why when we write out a number, when we think about our decimal places, we have the tenths, the hundredths, the thousandths. Those are all powers of 10. And then we have our whole numbers, our tenths, our hundredths, our thousands. It's all powers of 10 all the way through. That's why we count to 10 and then we start over again, right? Count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. and then we start over again. Okay? So it's called the common log with a base of 10. If you see a log that does not have anything written as a base, the base is 10. Okay? So with a common log, we don't have to write the base of 10. It's understood. Just like when you do a square root, you don't have to write the 2 for the square root, but you do for any other type of root. Same thing here. If it's a common log, we don't have to write the 10, but you can. It's not wrong to do it. But if you see a log with nothing written, that means the base is 10. The calculator can evaluate a base of 10 log. The other kind of log that a calculator can evaluate is what's called a natural log. A natural log has a base of e, but instead of writing it as log with a base of e, we give it a new name, and we call it ln, which stands for natural log, but it's backwards because it's in like Latin, right? So then it's like log natural. Okay. It's called the natural log because it actually occurs a lot naturally in nature and in science. So we will talk some more about some practical applications of natural logs and of the number e and why they are very important in the sciences, but that's why it is called this. And it has a base of e. So we don't write the base, but the base of the natural log is always e. And your calculator can evaluate those. Okay, so the first question asks us to find the log of 5, correct? Okay, so there's no base written, which means the base is 10. Your calculator has a common log or a log base 10 button, and it is right next to the 7. So right next to 7, we have a button that says log, and that is assumed a base of 10. If the base is anything else, your calculator can't do it. Okay, so if it says log base 4, log base 2, log base anything other than 10, your calculator can't do it, and you have to use one of those methods that we did on the earlier problem to try to figure it out. But we can do a base of 10, so log of 5, you just type it in, and go to about 3 decimal places or whatever your directions. And again, what this is asking, a log is asking the question of the base, whatever the base is, and in this case the base is 10, to what power gives me this number. So this is saying 10 to the what is equal to 5. Okay? That's what a log is doing. That's the number that is popping out, is giving us a power. A log is giving a power as an answer. So 10 to the what is 5, and we could check that. Does that really work? Is 10 to the power of this answer that we got 5? Because I rounded it off, but it's actually right. Your calculator can also do a natural log, which is a log of base e, and it has that button right by the other log button over here next to the 4. So the ln is the natural log, and it has a base of e. Then we just type in 0.1. And we get our answer there. Okay? And again, it's asking the base to what power gives us that number. So the base is e, so it's asking e to the what is 0.1. And this is our answer. So your homework tonight is from 8.4.